Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form the partial differential equation by eliminating the arbitrary constants from log z equal to a log x plus square root of 1 minus a square into log y plus b. So here we are asked to find the partial differential equation by eliminating the arbitrary constants from this equation. Okay. Solution: given equation log z equal to a log x plus square root of 1 minus a square into log y plus b. Consider it as equation number 1. Now let's partially differentiate 1 with respect to x and y. We'll begin with the partial differentiation. Firstly we'll partially differentiate 1 with respect to x. Partially differentiating 1 with respect to x. See here, z is a function of x and y, where x and y are independent variables and z is considered as a dependent variable. A and b are arbitrary constants. Okay. Just apply dou y dou x on both sides of 1. Okay. Partial derivative of log z with respect to x is 1 by z into inner derivative dou z by dou x equal to partial derivative of first term of RHS plus partial derivative of second term of RHS plus partial derivative of last term. Here we are partially differentiating with respect to x, so we'll treat y as constant. Here the total term is considered as constant, so partial derivative of this term with respect to x will be 0, and we can write this term as a into partial derivative of log x. Okay, since we know that partial derivative of z with respect to x is p, we'll just use this notation. Okay, dou z by dou x equal to p, then this becomes 1 by z into p equal to a into dou by dou x of log x plus partial derivative of a constant with respect to x is 0 plus partial derivative of a constant with respect to x is 0, right? Which gives us p by z equal to a into derivative of partial derivative of log x with respect to x is 1 by x. Okay. Which gives us p by z equal to a by x, or just bring this x to LHS, you'll get px by z equal to a, or we can write this as a equal to px by z. We'll consider it as equation 2. Now let's partially differentiate 1 with respect to y. Partially differentiate 1 with respect to y. Just apply dou by dou y on both sides of the equation. So you can skip few steps if you feel it's avoidable. Okay. Partial derivative of log z with respect to y is 1 by z into dou z by dou y equal to, here we are partially differentiating with respect to y, so we'll treat x as constant. Okay. Now partial derivative of first term of RHS with respect to y plus partial derivative of second term of RHS plus partial derivative of last time, right? Since we know that dou z by dou y equal to q, we have this notation, so let's replace it by q. You'll get 1 by z into q equal to partial derivative of a constant with respect to y is 0, plus here you're having a constant square root of 1 minus a square, so we'll write this term as constant into dou y of log y plus partial derivative of a constant with respect to y is 0, which gives us q by z equal to square root of 1 minus a square into partial derivative of log y with respect to y is 1 by y, right? Now we have qy by z, we'll just take this y to LHS, you'll get qy by z equal to square root of 1 minus a square. Consider it as equation number 3. Now observe 1, 2 and 3. See, by replacing 2 or 3 and 2 and 3 in 1, just by substituting, in other words we can say by substituting 2 and 3 or 2 or 3 in 1, the arbitrary constants won't get eliminated, okay? Won't get eliminated. B remains the same, right? So it is not possible to substitute 2 and 3 or 2 or 3 in 1. So what we'll do is we'll just observe 2 and 3. So here we have a possibility. Here you're having a square, right? We can just replace this a by px by z using equation 2. So let's replace a using 2 in equation 3. We have 3 qy by z equal to, it's q. qy by z equal to square root of 1 minus a square. Since a equal to px by z by 2, right? Just replace a by px by z, then you'll get qy by z equal to square root of 1 minus px by z whole square, which gives us qy by z equal to square root of 1 minus p square x square by z square. Just simplify it. qy by z equal to square root of z square, 1 into z square minus p square x square by z square. qy by z equal to, we can split the square root as square root of z square minus p square x square by square root of z square. Since we know that square root of a equal to a power 1 by 2, so now consider square root of z square. We can write it as z square power 1 by 2, right? Also we know that a power m whole power n equal to a power m into n. So we can write z square power 1 by 2 as z power m into n, where 2 gets cancelled, we'll get z, right? So square root of z square is z. Right? Z gets cancelled and you'll get qy equal to square root of z square minus p square x square. Now by squaring on both sides, the square root gets cancelled. qy whole square equal to square root of z square minus p square x square whole square. See, consider the RHS part, square root of z square minus p square x square whole square. We know that square root of a equal to a power 1 by 2, so square root of z square minus p square x square can be written as power 1 by 2 raised to the power 2. Since a power m whole power n can be written as a power m into n. So we'll write this as 1 by 2 into 2, where 2 gets cancelled. This gives us z square minus b square x square, right? So we can write this as q square y square equal to z square minus p square x square, since square root of z square minus p square x square whole square is z square minus p square x square, right? Now bring this term to LHS, you'll get p square x square plus q square y square equal to z square, or we can write this as z square equal to p square x square plus q square y square, right? This is the required partial differential equation. This completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.